Good evening and happy Halloween. Thank you for all joining me to talk about the evolution of .NET. It's really quite a pleasure to be here at Build with all of you. Last night we had a lot of .NET developers join us and meet the .NET team, and that was really quite a pleasure. So for all of you who were here last night, thanks for joining me again. So I'm the only person standing between you and the after event in the field, so hopefully you'll enjoy getting to spend some time in the rain. But I'm going to spend a lot of time talking about how we've developed .NET over the last 10 years and where we're going with .NET. So our agenda today is going to be talking about, first, the history of .NET. So I'm curious, how many people who have been at the PDC early in 2000 or 2001? So a good amount of the room. So this is going to be a fun history, getting to see some of the slides and some of the content from those presentations. Then we're going to spend some time looking at where .NET is today, and then start talking about what is in our minds as we're thinking about .NET for the future. So that's pretty much it. Let's get started. So this is .NET's 10-year birthday. And so if you were at the event last night, we had party hats, and that's because on February 2002, we shipped .NET 1.0. So this is our 10-year birthday. .NET's made a decade, and we're really proud about the progress that we've made. And that means that we're quite reflective about what we've accomplished and what we want to accomplish for the next 10 years. And so as we think about it, we want to start saying, what is .NET? .NET, when we think about it, really fundamentally comes down to programmer productivity. This is the official definition of .NET from Microsoft, that it's to aid developers in what they want to accomplish on any platform, service, and device. And we'll see that a lot of these thoughts are threaded throughout the history of .NET. But before I get there, there's one point that I just want to kind of come to that we think about every day when we're building the .NET framework and the platform. And it's this idea of the pit of success. I just want to read it out loud. This is a quote from Rico Mariani, who was one of the early performance architects for .NET. The pit of success, in stark contrast to a summit, a peak, or a journey across a desert to find victory through many trials and surprises. We want our customers to simply fall into winning practices by using our platform and frameworks. And to the extent that we make it easy to get in trouble, we fail. So that idea that whatever you code and whatever you accomplish, we want you to just, by default, do the right thing. And so we'll see some of that as we go through the history and what we've done today. So we'll start with a history tour. And a good question is, why are we talking about the history of .NET to begin with? A lot of you have been at PDC, and for some of this will be nostalgic. But I really do want to kind of repeat a quote that I find very inspiring from Winston Churchill. It's simply, the farther you can look back, the farther forward you are likely to see. And as we have questions about where .NET is going and what its purpose is and what its opportunities are, you'll see that we've consistently been on message to three things. And these are the enduring themes of .NET that have lasted throughout. So throughout this presentation, I'll be coming back to these three things. The first one is that we're consistently broadening the support of .NET to new platforms. So early on, it was simply Windows. And then came .NET Compact Framework. We had tablet PC back in the early 2000s. We've had web. We've taken it to the internet with rich internet applications. And we're seeing it today. .NET is a critical part of the Windows Store proposition for tablets. The second thing is this time to solution. It getting better, and this is developer productivity. Normally, we measure developer productivity in how many lines of code does it take to accomplish a specific task. And if you take the full accumulation of all of the .NET features that have come out over the last 10 years, whether that's LINQ and async and generics, the amount of code that you have to write today to accomplish a task that you could have done 10 years ago is quite monumental. Thousands of lines of code are now representable in just one line of code. It's quite great. And the last thing is performance. And this is where .NET has a unique opportunity, because .NET uses both a common language runtime as the underpinning of most program execution, and then an entire framework and your application. So we have multiple opportunities to help you improve performance for your application. We can just make it better in the runtime itself. We can make the libraries better for leading you to performance. And we can build diagnostics and tools so that the code that you write has much better performance. So these themes you'll see over and over. So we'll start with 2000. And this was the introduction of .NET in Orlando. So I saw a few of you raised your hands. And obviously, when we think about the platforms, we started with Windows. And at this same time, we announced the fact that we were standardizing .NET through the ECMA standards body. I think that by itself was the first thing that showed Microsoft's commitment to platform adoption across all platforms. And that's something that we see too today. Obviously, productivity at that time was managed programming over and over. We'll talk a bit more. And ASP.NET. And ASP.NET is just one of those things that continually makes things better and better for web programming. And lastly, performance. The fact that we created a type system that let you choose virtuals or non-virtuals, struct data types, and delegates, gave programmers far more control over their code to accomplish the performance they needed. But not to be left last is garbage collection. That you'll see even today is one of those opportunities where we can make application performance even better without your help. So I have a video here of Bill Gates introducing .NET. And you'll see at the very beginning of .NET, we were even talking about it as an evolution. So let's take a minute and just listen to what he had to say.
And so there's many elements in this .NET platform: authentication, scheduling, storage, security. There's a lot of very powerful demands people have against this platform in terms of how does it preserve privacy. But the role that the platform played in the past and the role it played in the future is absolutely the same. The things that are built on top will probably be relabeled. Today we have a world of applications and websites, and we think of those as two different worlds. Well, in .NET, those become one thing. Some websites will be richer applications than others, but essentially everything that was an application becomes a website.
And that's kind of an amazing thing. That was 10 years or 12 years ago when we started talking about .NET as an opportunity to start taking applications out of the client-based world over into this new hybrid world where we were combining the cloud as well as the client. And so just to introduce some of the ideas that were there, .NET was really the beginning of this idea of a unified type system. And that was quite a novel thing. Managed programming at the time is something that today we take for granted, but it really is the underpinning that's helped us succeed in the long run. We've made incredibly good architectural decisions that have lasted the entire time. We also see that this idea of robust and durable software, type safety, versioning, all of these things are concepts that have really still affect us today as we think about how to move forward. But I think the one thing that started off with .NET, and it still matters to developers today, just in a different form, at the time was just investing in your existing code, preserving that investment. And so at the time, we had a lot of VB6 code, we had a lot of C++ code, a lot of ActiveX code, and we wanted to make sure that you could take advantage of that in your application. And so today, a lot of us are now in kind of a different world where we care about the existing code that we've written in .NET, and we want to apply those assets to our new work. And so it's interesting to see that that focus on investing in your existing code and your existing skills still matters to us today. The other one is this idea of CLS, that we wanted to bring as many common, it's the common language runtime, but as many languages to the platform as possible. And this started off part of the standards effort, and we see the standards effort going very well even to today. The first standard for .NET was approved along with C# in 2001 in December. And we're actually now starting our 4th iteration of the standards effort in cooperation with other companies in ECMA that still rely on .NET today. And so now we're into 2001. .NET hadn't quite shipped yet. That happened in 2002. And so we're starting to refine our message. For those of you who've been at Microsoft for a while, you probably remember that we labeled every product with .NET at the time. And it was kind of a fun exercise to take .NET off of every product. But I go back to what is .NET? .NET is the idea that we want to take your skills and make you productive building things with services and devices. And so we did end up shipping .NET the following February. The things that we introduced at this time, we were starting to pick up good momentum. We introduced .NET Compact Framework. We introduced the tablet PC. And obviously, we had the ECMA ratification. This was the period of time when we started talking about the digital decade. So we've finished the digital decade. We're now into the next one. And we also, in the following year, in 2002, introduced Visual J#. So we're continuing to expand productivity, focusing on trends and things that people were caring about at the time. So I've this slide that kind of repeats itself throughout all the PDCs, which is really this idea that we're combining clients and services and servers together to create the applications of the future. So it's really interesting to me to kind of look at the archaeology of our lineage in .NET, and we're still facing these problems today, still making improvements. The themes are still there. So I have another talk where Bill Gates talks about .NET again, with a bit more of a refined message.
So .NET depends on 3 big bets. A big bet around XML, a big bet around a new platform, a platform with smart clients, rich servers, connected by a number of services that are always available out in the internet. And finally, these applications, when you get onto the device, have to tailor their appearance and their richness to that device. On the device, we need a level of richness and ease of use that we haven't had before. We're not just talking about taking a browser and pointing it at a single website where you can read the information by turning the device into a terminal. We're talking about an environment where information from all systems on the internet can be gathered together into a rich view. And the involvement of the user, their creativity, their annotations, all of those things get involved in interacting with that application. It's a vision that includes peer-to-peer as part of the design. It includes the ability to work offline with that information and have the information automatically synchronized with all the other devices as soon as you're connected.
So again, quite prescient words from Bill Gates. So skipping forward to 2003, this is definitely the place where we really do have significant steps forward with .NET. We announced WIDBE, and so platform support. We're expanding to SQL Server, being able to write queries with .NET, as well as 64-bit programming. It was just in 2005 when 64-bit programming and PCs were actually quite available. Productivity, obviously, with generics, broad library support with things like WCF and WPF, and then RAD development, edit and continue came forward. And for performance, this is the place where NGen really made a step forward. NGen is the technology underneath the framework that helps generate native code ahead of time. And so if you look at this, the base innovations were there across the board. And if you look at the C# enhancements, you can see just generics by itself is one of those things that has led to a strong line of future innovations. The one thing that I actually really think is another really important innovation here is partial types. And this is one thing that .NET does incredibly well, particularly compared to a lot of other development environments, is the idea that we invent things to make tooling better. So partial types, something that many of you probably don't use yourself, but the tools that you use do use them. And so they're able to extend the code you write without interrupting the code that you're authoring. And those are things that we still like to do a lot of, is how do we make the tooling a better experience for you? .NET's not just about programming and the languages and the libraries, it's really about the tools as well. And so along with that comes this idea of that pit of success. The design guidelines kind of really got sharpened and focused to the point we could author a book. And if you look at the design guidelines today, one of the important points is that if you could come across one library that you would be able to jump to another library and still make use of it. We're using those same design guidelines today to help us author new APIs, particularly with the Windows runtime. And so it is that history, that experience that we've built up with .NET that is still paying off quite largely today. Jumping to 2005, .NET 2.0 shipped at this time, so we're starting to look forward. And this is that point where .NET switches over to being possible for mission critical and that enterprise ready focus. We started announcing LINQ and the dynamic language runtime. So if you look at the design guidelines for the future of C# at this point, the one that I actually want to draw your attention to is that last point, is 100% backwards compatibility. That's still a bedrock of how we think about ourselves with .NET today. As we carry it forward, investing in your assets is important. And so the compatibility of the code that we author for you still needs to be there so you can take that bet. And so obviously, this is a point where, again, C# is able to kind of keep taking a lot of innovations forward, still building on generics and other features. And really, .NET 2.0, the CLR at that time, had so many things in it that C# has been able to kind of keep extending itself by only using things that have been in the CLR at that point. And obviously, LINQ is something that has significantly changed the way that you can write code for C# to query a number of data structures. The other thing at this time is the idea that there's now a spectrum of programming languages. So you see at one side dynamic languages, and on the other side more statically typed languages. It is absolutely fun to get people who are advocates of both of those into a room and put them into a boxing ring. It's the best time I usually have at work. So, but you kind of see this is a point where we're starting to invest in dynamic because that's becoming more important, and you'll see that show up even more so later. Next, 2007, we have Mix. And at this time, I think that the rich internet application was an important trend that was something that a lot of developers needed. And we wanted to make sure that .NET developers could take their skills and apply them to that space. And so we introduced Silverlight. And Silverlight has done a lot of really great things for .NET. It's incubated new deployment models to make things easier. It's certainly incubated a lot of things about performance and how to package applications. We've taken that experience and applied it to a number of platforms going forward, including the phone, as well as the way that we've designed things for Windows 8. So again, you see this pie chart where you see the combination of the web and desktop and services. It's still true in 2007 as it was in 2001. And then in 2008, we introduced .NET 4. This was also a reflective year for us because 2008 was 10 years after the .NET project had really begun. So it was 1998 when we started working on it. And so for productivity, we introduced code contracts and a number of other improvements. But most of all, the thing that we've built that we're still going forward with is the parallel framework and TPL. This is also the time where we started realizing the size of the framework really mattered to all of you. So we started taking efforts to reduce the size of the framework. And the trends that Anders brought up at this time was that there's dynamic, declarative, and concurrent. And all of those were starting to show forward to influence C#. And so we start seeing this same slide with the arrow pointing up going forward. Dynamic programming was the thing that we introduced predominantly at this time. We also introduced other things like interop, which was again about reducing the size of an application. PDC 2010, this was where we introduced asynchronous programming. And again, you see this chart. The other thing that we talked about with C# and Visual Basic is the co-evolution of these two. In asynchronous programming, we'll talk about again just a bit later, but really something that helps you write code very easily and helps you fall into that pit of success for concurrency. And then, of course, last year, jumping very quickly, was build. And the thing that we introduced at that time for C# was the Windows runtime in addition to async. And the idea of Windows runtime, the slide from build last year, was that when you're programming against Windows runtime with C#, it looks like you're just programming with .NET. We're making it feel just like you are programming against another .NET library. So that takes us to the present. Like, we're now here. We just released .NET 4.5 3 months ago, and it's had quite a great success. We're upwards of 4 million downloads at this point. And that doesn't even include all of the downloads that come from Visual Studio or Windows 8 or Windows Server 2012. So we're off to a good start. We'll just come back to these enduring themes. Broadening support for the platform and industry. Those are the things that you've seen over and over through those 12 years. Developer productivity and performance. So when we think about what users want today, they want business-compatible applications. And the thing the trend that's influencing us right now is this consumerization of IT. The IT departments are now letting people bring their own device, the bring your own device trend, into the office. And so in order to build applications that will work for them, I have to now target multiple platforms. And that's a new trend. It means that IT departments can't control exactly what you're doing. And that's also influencing how we're thinking about taking your skills with .NET forward. The second thing is this fast and fluid experience. Over and over, we find that users who have responsive UIs that can try things out and experiment are much more likely to try things out without going to their friend to ask how to do something. And so that's something we'd like to encourage because that gives us all time back to program a few more things. And the last thing is this modern connected app. We talked about it in 2000 and 2001, the idea of combining the cloud and services with the client to build things. This still rings true today. And so any app can be better by just connecting it to a service, whether that's a service that saves files like SkyDrive or a social network like Facebook. And just by adding a service, it makes your app more appealing and better. And so what do developers want? The developers want to target multiple platforms. They want to target Windows 8. They'd like to target the cloud, whether it's Azure or Windows Server 2012. And they'd like to target Windows Phone. And so how does .NET help? .NET has a solution to take all of these together and bring them forward to today. So I'm going to skip over to a demo now to kind of show exactly how all of this works. I have a demo that I've built, and at TechEd, I actually showed building a lot of this app end-to-end. And so I'm not going to build the app entirely end-to-end for all of you. But if you'd like the code, I've made the code available for you. I'll link to it at the end of the presentation. So the basic architecture of this app is that we have a database at the bottom. We created the database using a new feature in Entity Framework that lets you build a database by just writing code. It's code-first Entity Framework. Then on top of that, we're going to use Web API that lets you build HTTP REST services. And this is a pattern that lets you start writing code, separating it from the server and the client in an industry standard way so that you can write most of your code on the server and connect it through very easy REST services for all of the different clients that you might author. And then on the client, we're going to use async to make a great fast and fluid experience, and HTTP client, which is a new way to access a web service in a very easy one-line way. So let's skip over to our code. So before I do anything, I just want to actually bring up this. And so notice that this is going to take a few seconds to load all of the content. And that's because we didn't use async to actually separate the content out. And so I want to kind of go through and make it a little bit better. And so if I had an even slower internet connection, I could go through and load each of these tiles one at a time. So this is just a .NET feature catalog. It lets me explore all of the different features that are in .NET 4.5. And this is a Windows 8 Store application. So it uses the Windows Store, the .NET profile for the Windows Store, as well as using the design language for writing these apps. All we did was take the template out of Visual Studio and just start building code from it. So let's actually take a look at this. The code that I have written here shows that I'm just getting the entire database and returning it. And so I'm using Web API here. Web API is a new library that works with ASP.NET that helps you build HTTP REST services. HTTP has a set of verbs. Most of us know the get and post verb. And all we're doing is mapping methods to that here. And so I'd like to write a new API that lets me just get one tile at a time, get the information from that one tile. And while I'm doing that, I'm going to show how to use HTTP services to actually take advantage of the protocols that HTTP has. So the first thing I'm going to do is build a new method. And you'll see that the first thing I'm doing is actually building something named get. So actually, because get is one of the verbs for HTTP, all I have to do is name it get or something that begins with get. And I'm going to use an ID. So it's fairly straightforward. All I want to do is gather one thing out of this database that I've created using Entity Framework. And get the one thing that represents that ID. Fairly straightforward. So at this point, I could actually just return that feature. But since this is something that has an ID, what if that ID was not found in the database? What would I do? I'd like to send a customized message back to the user. So if feature is null, I'd like to actually return a separate request that says that the thing was not found. And so that's an easy way to now take advantage of HTTP. So if I'm in my browser and I executed the code against this, I could actually see that code in the header response. And so to finish this off, all I have to do is send a successful return. And so now if I call this API, I'll get just one tile at a time. So I'm going to switch over now to the client side of the code. And so over here I've got the web backend. What I've done here is I've subclassed the HTTP client. And so the only thing I wanted to do with that is just make it a bit easier to access the particular code that I'm writing. And so what you'll see is that I have a URL. And so in order to use this HTTP client, all I have to do is create it and then pass a URL to download some code. The other thing that I'm using here is JSON.NET. JSON.NET is actually not part of the .NET framework. It comes from the NuGet library. And so Visual Studio has more integration with NuGet today. And so you can get very popular libraries and download them and integrate them directly into your project with just a click of a button. And you see things like JSON.NET on the list here, as well as jQuery and Entity Framework. So now I just need to go over to my code here and actually fix this. So as I do this, the first thing I want to do is change this code, and how I'm going to actually download each tile at a time is call the server, get a list of the integers for all of the IDs that are on the server, and then make a separate call for each of those integers in that list. So I'm going to get a list of int by calling the features summary. And I'm going to change this to a list of ints so you'll see the error. So now you'll see this error. And when I do that, you'll see that I can't implicitly convert something that's a task type to this list event. What's happening here is I need to use this new feature called await. This is an example of that pit of success. As you're calling an API that's doing I/O, which I'm calling into the network to get a response, I just need to wait for that. And so if I did that on the UI thread, I would pause the UI. That's not good. And so all I'm doing here now is writing await, and it's the errors in the code that's leading me to do that. By doing await, I'm breaking up the code and able to return immediately to the UI so I'm not blocking. When that I/O operation finishes, I'm going to come back onto the thread pool and continue the code separately. So continuing on, we can again do this and call that API that we created to download one thing at a time. And we're now going to, again, await on that download. And this time I'm going to get a feature data item for that. And so with that, I should be able to run the code now. And when we load this, you'll see that everything gets loaded one at a time. And I can go through this and see the code showing a much better experience. So even as I'm loading more and more things, I can go in and interact with the entire application. So with that, let's actually take a look at some of the things that are in .NET 4.5. The first thing I want to point out is ARM support. And so this is another example of broadening the platform support with .NET that we've brought first-class JIT compilation and code generation for the ARM processor in .NET. And obviously, I've covered the fact that this application itself is written with the .NET API and using Windows Runtime to build the entire UI. Some of the fun things that we can look at is the zip archive. And so we've listened to a lot of feedback. And so programmer productivity improves by adding things like building zip archives directly into the framework API. We also talked about Entity Framework. I'll talk about portable class libraries in a second. But HTTP client, again, is just one of those things that lets you access a web service in just about one line of code. And then if we look at some of the big things that have mattered to .NET right now is I will first start talking about background garbage collection. So garbage collection is just one of those opportunities where we get to improve performance for your application without you having to do a lot of work. Since the beginning, the design of the garbage collector in .NET has really been about it being an auto-tuning garbage collector. And so that means that when you upgrade to a new operating system with a new version of .NET, you get these benefits for free. The chart that's here is a chart from Bing. Bing writes a lot of their application on the .NET platform. And in May, they upgraded all of their servers to Windows Server 2012. So you can see before that time, they were spending anywhere between 8 and 7% of their time in garbage collection. That meant that their application was paused for 8 or 7% of the time. It was a lot. But as soon as they upgraded, that dropped to roughly around 2% of their time in garbage collection. And this is taking advantage of hardware trends like right now with multi-core. We're able to do a lot of the garbage collection for the largest heap, the Generation 2 heap, in the background while the application is still running. And so we're able to reduce the amount of time we're in garbage collection. And so I was talking with someone just last week about whether there's been actually any improvement in concurrency over the last 10 years. He was kind of investigating this and saying, we keep saying the same things about concurrency. We're actually seeing such an amazing motion forward right now. The fact that .NET is taking advantage of concurrency on your behalf, and the fact that you have async in a way that's just leading you into the right patterns. The next one I want to bring up is something we call multi-core JIT. And multi-core JIT is also taking advantage of the fact that when you have more than one core, we can JIT all of the code ahead of time. And so in order to do this the right way, without JITting code that you really don't need, which has the problem of ruining your cache, instruction cache, we need some profile data. So with just 2 lines of code that you add to the beginning of the startup of your program, you can improve startup time for your application by using multi-core JIT. And again, this is an example from Bing, where just by upgrading to Windows Server 2012, ASP.NET already takes advantage of multi-core JIT for you on your behalf. They were able to take the startup time of one of their applications from almost cut it by half. And so quite an important improvement. And then the other thing that I want to bring up is this idea of reducing the footprint of .NET. So what I'm showing you here is a chart of all of the assemblies in .NET that are engined. And so on the bottom is what it was in .NET 4. We engined everything, because why not? With .NET 4.5, we became a little bit more smart. We used a lot of information from studying applications out in the wild. What are the actual assemblies that need to be out of the box compiled to native code? And that's a much smaller set. And by doing that, we're saving a lot of disk space. I'll talk about disk space again in a minute. But by doing this, we were able to make sure that .NET 4.5 was much smaller than .NET 4 while still providing all of the capabilities. And this is combined with another feature in Windows 8 called Automatic Engine. So we'll actually track the usage of applications that come from the Windows Store. And if an application is used enough, we'll go ahead and automatically engine that for you. And that's something that developers always had a hard time to do. So we're now doing that for you automatically. So that pretty much concludes what I wanted to show you in the demo. And so just go through and review another thing is another feature that's going to be very important to .NET, and you'll see this being kind of a foundation for a lot of the things that we do in the future. It's portable class libraries. Now that you are a developer working with so many different platforms, one way to deal with that is move a lot of the logic up to the cloud and have more of the computation and features done on the server side. Another way is to write a single binary that you can use in all of these platforms, and that's what the portable class library feature does. There's a talk on Friday that I'll refer you to that goes into this in depth to show you how to use portable class libraries so that you can deal with the differences across so many different platforms. So reviewing those enduring themes and how they apply to .NET, things to check out when you're thinking about broadening platform support. We now have .NET for the Windows Store, WinRT, and certainly taking trends like modern HTTP programming, and of course the ARM processor. Then for developer productivity, you can check out Async, the portable class libraries feature, all the work that we did with Entity Framework, and a number of the features that came from your requests through user voice. And then lastly, with performance improvements, background garbage collection on the server. So far, we have heard over and over from so many different customers great things about this. So we'd love to hear from you if you have a great story as well. Multi-core JIT I talked about. Another thing that we focused on was the working set for ASP.NET. This is particularly useful for an environment where you're hosting many websites. And so a site that's used infrequently usually gets discarded and then later rehydrated when someone else goes to that site. Well, if we can put more and more sites onto a server by using less memory, that means the site responsiveness for all the websites on that server go up. So we use less memory when we're using ASP.NET now. And of course, I mentioned automatic NGen. So yesterday, we had a lot to talk about with Windows Phone. .NET for Windows Phone has a lot to offer. The first thing I want to point out is that we replaced the compact framework with the Core CLR. And Core CLR has been the runtime that's largely shared with the full CLR that's been part of Windows since the beginning. It's also the same runtime that we built for Silverlight. So it's incredibly well used and well designed. And so we brought that to the Windows Phone, which means that you get all the benefits that come with the years and years of experience and work that's been put into the full Core CLR. It means better garbage collection because you now have a fully generational garbage collector, a much better JIT that's more optimizing, and certainly the libraries get far more in sync with what's going on in the whole .NET framework. And so the key innovations carrying forward from .NET 4.5 as well as Windows 8, carrying forward the Windows Phone runtime, those are things that .NET developers will be taking advantage of for Windows Phone 8. And the last one is this compile in the cloud feature. So I'll give you a sneak preview of what that looks like. And on Friday, again, there's another presentation that goes into depth on exactly how that works. So compile in the cloud, the first thing you have to ask is why? What is it getting the developer or the user? And it really comes down to the user experience that we cared about. The user experience is how long does it take to install an app? When I update a system, how long does it take for me to be able to use my phone again? When I'm installing an app, do I get to use other applications, or is it just so slow? All of those are problems that come down to optimizing code during the install time or a servicing time. So if we can improve that experience and still get much better code, we'll be better off. And so what Compile in the Cloud does, along with a number of the other features that come from Windows Phone 8, along with the Core CLR, is that you can expect an average of 2x performance improvements for your applications, even the ones that are already in the store on release hardware for Windows Phone 8. So what does it look like? This is fairly familiar. We compile our C# code, go directly to MSIL assembly, and after that, we take it and download it to the store. This step of compiling it to an NGen thing is all about startup performance. Like if I pre-JIT all of the code and then save that in a native image, I have improved the startup performance of the app. The problem with that is that you're basically running a compiler on your phone. And that's not the most efficient and effective way to use your phone. So what Compile in the Cloud does is use a new technology we call MDIL. And so MDIL is effectively a 90% format. We compile it 90% of the way to the target architecture. MDIL stands for Machine-Dependent IL. And so that MDIL assembly is then downloaded and finally converted to a native image. And what we're doing there is basically still preserving the ability to update the framework, make changes, so that when a servicing update to the framework happens, all of the apps get back to working very quickly without the user being interrupted by that servicing update. So we'll go into a lot more depth about MDIL on Friday. But MDIL is one of those things that definitely you can look at and see. This is just the beginning of a new wave of features and things that we're able to build off of. It's an investment that's going to pay rewards for many years to come with .NET. And so when we start looking forward, we're going to come back to those themes. But I'm going to take a quick sidestep and talk about Compact Framework. Now that Windows Phone 8 no longer includes the Compact Framework, what does it get used for? And it's still in these compact environments. There are a lot of devices that still want to use less than 256 megabytes of memory. And there's quite an environment for those across many scenarios in industry, industrial automation, and vertical scenarios as well. So next year, we're going to ship the new version of Compact Framework. We're calling it Compact Framework 3.9. And it's going to have a number of new features like a generational garbage collector, better code generation for ARM, more multi-core scenarios so you can write multi-core safe code, as well as code sharing so that you use less memory when you're using more than one application on the device. We're also going to provide this ability to develop in Visual Studio 2012 to target Windows Embedded Compact 2013, which ships next year. So a lot has changed, and this is a chance for me to quiz the audience. Over the last 10 years, just thinking about 10 years ago, 12 years ago, what was the average amount of RAM on a machine? 64 megs. 128, 256, okay, we averaged that out. It was 128. So 128 megabytes of RAM. Today, an application using less than 128 megabytes of RAM is kind of, wow, that's great. We see that. And so you think about, we were designing .NET for the machines of the time. 128 megabytes of RAM for the GC to go through was, kind of what we had to think about. Now we have machines that regularly sell for, 8 gigabytes, 16 gigabytes of RAM. And, you see applications that easily have working sets that are many gigabytes. And the GC has to go through that. And so a lot of the things that we think about, a well-architected application 10 years ago, very different from today. How about hard drive space? How much space was in a hard drive? 20 gig? 6.4? Quite specific. Yeah, so it was a year of a lot of people predicted at that time that you could have so much space that space no longer mattered. Well, we're living in a world today where people actually want to have pictures and videos of their kids on their machine rather than the .NET framework. So that's something we're thinking about. Another one that's actually quite important is virtual machines. Because the .NET framework is part of the OS, if we can reduce the size of the .NET framework, we can put more virtual machines on a single physical machine. And that actually is cost savings. How about internet connection speed? What was that like 12 years ago? It was dial-up for sure. ISDN. So it was about 50, those 56K modems, and so AOL was still going strong. The the thought there is when we first designed .NET, something we thought about relative to disk space was that the download size mattered far more than the disk space that we took at the end. And so we could expand it and take up a lot of disk space as long as the download side was small. That's kind of what NGen is like to us today. NGen just happens to be like one of the best compression technologies ever. That's a joke. And it really is one of those things. Today, we download gigabytes and gigabytes of data just to watch movies every night. So again, another thing that's changed. Downloading something in the moment, is far less expensive than taking up a lot of disk space up front. And this one should be easy. The whole room should answer. How many processors were there? One. So obviously, we start looking at the trends right now. We're taking advantage of the fact that all of you have probably dual processor or more in almost every device. You'll see that Windows Phone now has dual processor phones. And so we're taking advantage of that in the runtime. Again, with garbage collection and multi-core JIT and all of these other scenarios. And you will be taking advantage of these too with async. The fact that that pit of success, the library will lead you to it. And so if we come back to those enduring themes, this is what we're thinking about again for how do we focus on for the next 2 years. Broadening support for the platform, the time it takes to get to the solution, and performance improvements. And so what are the actual things that we care about when we think about these particular themes? The trends we're paying attention to. Right now, first and foremost, it's the device experience. The fact that I want to make sure that battery life, the I/O that's happening on the machine, that fast and fluid responsiveness of the application, and the whole UI still matters. The second thing is this first-class cloud experience. The fact that you're bringing so many different components together kind of melds into this next point of heterogeneous development. No longer do we think that the best thing is only going to be achieved when you convert all of your code to .NET. It's going to be when you take all of the pieces that are available to you and combine them together. And certainly another trend that matters to us that we're kind of investing in from the embedded side as well as the .NET micro framework is the Internet of Things. This idea of being able to take massive amounts of data and push it up into the cloud and analyze it. And you have solutions that make that quite prominent with .NET, including programming languages like F#. And then the last thing is this idea of targeting multiple platforms at once. The fact that now you're programming for the phone, you're programming for Azure, you're programming for Windows Server, you're programming for the desktop, you're programming for Windows Store. That's a lot of programming. And so if you can take all of that code and put it into one binary and reuse it over all of these scenarios, you're far more productive. And I think that's something we'll see more and more libraries trending towards that as well. And this is a place where NuGet is really something we're investing a lot more in to improve that. So the message that you get out of all of this, combining those trends with the enduring themes, is that when you bet on .NET, all of the code, all of the experience, and all of the skills that you have, something that we really want to take advantage of because we know you're building some awesome software. And so it's our responsibility, our privilege to be able to continue taking all the skills that you have and carrying it forward. So with that, I want to say thank you. There are 2 presentations I'd encourage you to go see. On Friday morning, you'll get to go to the deep dive into the Windows Phone kernel, which will explain more of the compile in the cloud. And then in the afternoon, you'll get to see how to use portable libraries. So I have about 7 minutes to entertain questions from the audience. What I'd ask is if you could go to the microphones to ask the questions. And if you do, I actually think because it's Halloween, I have glow sticks, which I'll throw in your general direction. Up on the screen here, I have some information. If you're interested in the demo that I showed in the middle of the talk, it's available via that link, and you can contact us via Twitter as well as through my email address. So thank you. Number 2.
Hi, thank you for a great session. Really enjoyed that. So my question is this, especially on the client, and not really on the server. I hear Microsoft saying that WinJS and HTML is the preferred development platform for Windows 8, Windows Store applications. I find this a bit bewildering because I see developers saying they want to program in .NET and C#. We also see Anders working on JavaScript and TypeScript, so there's concern about really whether Microsoft is still committed to pushing forward C# and .NET, especially on the client. So I wondered if you could speak to that.
Great question. So overall, just like how much commitment do we have behind .NET, especially across all these platforms? We're incredibly proud of what you can accomplish with .NET on Windows Store today. Overall, we're seeing the applications that people do create with C# on Windows Store. There's new apps being released via C# today, every day, and they're showing some of the best experiences possible. Simply the fact that JavaScript and HTML are something we're talking about really reflects that we're trying to attract all of the developers who can accomplish any skill to this platform. And so the fact that all of you are interested in writing .NET code for the Windows Store is something we absolutely want to encourage. We keep investing in that and making it better. We have a lot of plans and a lot to accomplish. So you really should be rest assured. These themes that we talked about, the device experience, coincides exactly with what we want to accomplish on both the phone as well as the tablet device in Windows Store. And Anders is still working on C#, don't worry. So, yes.
Well, I just want a glow stick, but no, actually. All right, all this stuff is cool, but unfortunately, most of us have day jobs that we have to actually do stuff to. So what's the best way to start learning all this stuff? I know we read blogs and do all that stuff, but it kind of gets ahead of us sometimes. So in your opinion, if we're have our 20 minutes a day maybe from a workday, what's the best way to actually figure out how to all the new fun stuff and how to use it?
Well, I guess good question. So there you go. If you want to learn something, I think the easiest thing for me is always get Visual Studio installed and then open a project and compile it. Just play around with that project, see what's there. Obviously, we have this demo that kind of shows you some of the new features if you want a quick and visual way of seeing it. But there's nothing better than just playing around with code. So even just taking the default templates in Visual Studio projects, it's a great way to start. Yes?
You mentioned being able to write in the future sometime one project that targeted several different platforms. That sounds awesome. Any estimate on the time frame of that? 1 year, a decade?
How about -3 months? Being able to take one project to target multiple platforms is the portable class libraries feature that we introduced. It's actually been around, and now we're building a much better Visual Studio experience around that. With .NET 4.5, it gets even better.
That's a project, though. I'm talking about an application.
So, okay, good question. Can an application be portable to multiple platforms? That's really an interesting question from is it appropriate for an application to go to multiple platforms? Is the UI and the experience that you want to be the same? If I have a 10-foot experience with the Kinect, do I really want it to be exactly the same as what I'm getting on the phone? At the end of the day, the abstraction level that a library provides, I think, will be getting higher and higher. And I think that's going to be something that's the confluence between experiences that we build in Visual Studio to produce better tooling, as well as the contributions of the community to take abstraction levels that include UI to a higher level in libraries. And that brings you closer to that. But I think at the end, you still want to ask yourself, is it really the right thing to build that same application on all form factors? So here you go. Watch out. So, yes.
Brandon, you've been talking a lot about the Windows Store, and that's what we're seeing here a lot. I'm not seeing a lot about desktop. A lot of us are on as business developers. We've got a lot of WPF apps. Mm-hmm. What is the story there? Are we going to get a .NET 5 sometime? Are we going to get this goodness in our real world?
So good question. How much can we provide with the desktop with .NET to keep improving things? You'll see that .NET 4.5 includes a lot of functionality that directly helps you with desktop applications, including, as pointed out, zip archives, multi-core JIT. A lot of these things are just things that are great for desktop. And I definitely would say you'll see us continuing that investment to bring libraries and other experiences to all platforms, including desktop. I think it comes back to this very frustrating experience I know a lot of people have, is that they do want to program for desktop as well as for Windows Store. And I'm sure, like many of you, when I start learning something, I go to the internet to go search, how do I do this? And right now it's very frustrating because I look up something and it only works on the phone, or it only works on the desktop, and it only works on Windows Store. I'd like to find something that works everywhere. And that idea that we can kind of unify the development experience across all these platforms really is the central point. And that means that we're going to add value across the board with .NET, not just to one of these platforms. So great question. So, darn. Okay. Oh, yes. Number one. Thank you.
My day-to-day job is working on a public-facing full trust XFAP. And my question to you is, I love the idea of .NET 4.5, but how do I sell people on the fact that there's no client profile anymore?
Good question. So there's no client profile. What is the reason for us kind of taking the client profile away? The first thing was back to this idea of size. The client profile was introduced with 3.5 SP1 and .NET 4 so that we could reduce the size. A lot of that was the fact that we couldn't easily find ways to package things to make it smaller than 50 megabytes at that time. We've become smarter about how to build setup software for .NET. And so .NET 4.5's installer is less than 50 megabytes. And that's the principal reason behind why we're able to provide the full experience. The second thing behind this is when you're upgrading from .NET 4 to 4.5, if you had the full experience or full profile installed with .NET 4, and we had a 4.5 client profile laid over that, that would create a mismatch in libraries that likely would result in bugs in your application that you wouldn't want to solve. So this was ultimately a way for us to make things much simpler for you at the same time as reducing the size of the setup. So that's...
I mean, just so you understand, right, to my users, unfortunately, this is quite a bit of extra time to bring the product down and get it up and running.
Understood. So I'll throw it this way. Pass it along. All right, I'll go to number 2.
Related with the other question for desktop application, which will be the future for VPF application or Windows Forms? Will there be a future for those or will it die?
Good question. So what is the future of WPF and WinForms? Both of these are things that are, we definitely see a lot of critical applications across the world depend on them. Visual Studio builds on WPF, so we'd like Visual Studio to keep working too. WinForms is another one that we continue to make investments to carry them forward. Relative to other UI platforms, we're definitely trying to bring up the UI platforms on phone as well as Windows Store, which are less feature-rich than what we have available in WPF today. So it's really a prioritization exercise right now to kind of make sure that we're bringing those features forward. But you can rest assured, those are things that, as things depend on them, we're not going to just abandon them. So, all right. Close. All right, number 3.